Conic sections. In this video, we're gonna summarize everything about conic sections. We're gonna go over conic sections. So why they're called conic sections? Notice we have a cone here. If I cut the cone by a plane, sometimes I'm gonna get a circle. So keep in mind, we're cutting a cone with a plane. Now it depends on the angle of the plane. Sometimes we're gonna get an ellipse or a parabola or a hyperbola. We're going to start with the first one. The equation of a circle is as such, where h and k are the center of my circle and r is the radius. In this example, the center is going to be 3, -4, and the radius is 5. In this one, the center is going to be the origin, and the radius is 4. Now, what's the equation of a circle of center 3, -1, and radius 4? This is the standard equation. We're going to take h and replace it by 3 and k by -1. And we're going to square the 4 to get 16. Therefore, the final result is going to be x minus 3 squared plus y plus 1 squared. Keep in mind, negative times negative is positive. That's how we got y plus 1 squared equals 16. So the center is 3, -1, and the radius is 4. Now we're going to start with another conic section, which is the ellipse. So the ellipse is a set of all points P in a plane, the sum of whose distances from two fixed points F1 and F2 is constant. So these 2 points are called the foci, and the midpoint of the segment connecting the foci is the center of the ellipse. Now in this example, we have the major axis as such and the minor axis, and always the vertices are on the major axis. So now we're going to see the standard form of equation of an ellipse, center origin. Keep in mind center origin. So we have the horizontal ellipse, where the major axis is horizontal with length of 2a. And notice where a is. Or we have the vertical ellipse. Therefore, the major axis is vertical with length of 2a. So notice where a is. So if a is under the x and a squared greater than b squared, we have a horizontal. If a is under the y and a squared greater than b squared, we have a vertical ellipse. Now c squared in both cases is a squared minus b squared. So we need to write the equation of that ellipse. So we have the vertices are on the y-axis. So the equation is as such because the center is the origin. Another example, the vertices are on the x-axis this time, and the center is the origin. So the equation is going to be as such. We need to graph this ellipse. This one here is horizontal, and the vertices are 3 and -3. And on the y-axis, we're going to take 2 and -2. So on the y-axis, we took the points 2 0, 2, and 0, negative 2, and on the x-axis we took the points negative 3, 0, and 3, 0. Now we need to calculate the foci. So we have the foci also on the x-axis with square root of 5 and negative square root of 5. Now here we have to divide every term by 400. Now this ellipse is vertical, where the vertices and the foci is going to be on the y-axis. Now on the y-axis we have the points 0, 5, 0, negative 5, and on the x-axis we have the points 4, 0, and negative 4, 0. And for the foci we have 3, 0, 3, and 0, negative 3. So these are the foci. These are the foci. Keep in mind the points we have. Again, we need to divide every term by 144. Therefore, we got x squared over 9 plus y squared over 16 equal 1, another vertical ellipse. So on the x-axis, we're going to have 3, 0, negative 3, 0, and on the y-axis, we're going to have 0, 4, 0, negative 4, and for the foci, they are also located on the y-axis with square root of 7 and negative square root of 7. So these are the foci. Let's see the points we have. Now, if we need to write the equation of an ellipse with foci, negative 1, 0, and 1, 0, and vertices. Now notice, because we have one of the coordinate of all the points we have is 0, so this ellipse is centered as 0. Now vertices, the vertices are on the x-axis. So the major axis is horizontal. We have the vertices, negative 2 and 2, therefore a squared is 4. Now we need to calculate b squared. We know that c squared equals a squared minus b squared. Therefore b squared equals 3. Therefore the equation of the ellipse is as such. Now the foci are on the y-axis, so the major axis is vertical. Keep in mind we have the vertices and we have the center. This is the center, is the origin. We know the vertices plus or minus 7. Now we need to calculate b squared. So b squared equals 33. Therefore the equation is x squared over 33 plus y squared over 49 equal 1. Now the standard form of an equation of an ellipse centered at h and k at a point different than the center. Now first, in this example, we need to locate the center. So the center is 3, 4. Then from the center, we're going to go 5 units left and right because a squared is 25, and 3 units up and down because y squared is b squared is 9. and that's my ellipse. Now these are the vertices. Also, keep in mind the equation of the vertices. So the vertices has equation h plus or minus a, and the foci has equation h plus or minus c, comma k. Now still here, c squared equal a squared minus b squared. So 25 minus 9, that's 16. So in our case, 25 minus 9, that's 16. So that's how we got C as plus or minus 4. So again, this is my a squared. This one is my b squared. And c squared is a squared minus b squared. First, we need to locate the center. So the center at 1, negative 2. From the center, we're going to go 2 units left and right, and 3 units up and down, and that's my ellipse. Now keep in mind, c squared is a squared minus b squared. So c squared is 9 minus 4, that's 5. Because we need this for the foci. But now the formula for the foci, therefore c is plus or minus square root of 5. Keep in mind, this is my a squared. This one here is my b squared. Now the equation for the foci and for the vertices, so the foci is h k plus or minus c, and for the vertices is h k plus or minus a. Where c squared is a squared minus b squared. Now here we have equation of an ellipse, so we use completing the square. We're going to use completing the square. So we're going to put the x's together, the y's together, and we're going to put the number on the other side. And we're going to use completing the square to rearrange this equation. Now we're going to divide every term by 4, by 16. We're going to divide every term by 16. Therefore, this is the equation of the ellipse. A is plus or minus 4, B plus or minus 2. The major axis is A, and the minor axis is 4. A hyperbola is the set of points in a plane, the difference of whose distances from two fixed points called foci is constant. So a hyperbola is the set of points in a plane, the difference of whose distances from two fixed points called foci is constant. Now the standard equation of a hyperbola centered at the origin is as such. Keep in mind we have asymptotes, and c squared here is a squared plus b squared. And these are the equation of the asymptotes. And the red part is the transverse axis, and the red part is the transverse axis. Now notice here a squared and b squared, the position of a squared and b squared doesn't change. It's if we're starting with x squared, we're going to look at, or if we're starting with y squared. Now we need to draw the following hyperbola centered at the origin. Keep in mind a squared is 9. Therefore a plus or minus 3. So the vertices are plus or minus 3. Now we're going to draw from the origin a rectangle by going 3 units left and right and 5 units up and down. We're going to take the diagonals of this rectangle. Then keep in mind the vertices are at 3 and negative 3. Now the foci, c squared, we have c squared as a squared plus b squared. So the foci is going to be at square root of 34. Now the asymptotes, plus or minus b over a x. Again, from the origin, we're going to go 4 units left and right, 3 units up and down, and we're going to draw a rectangle. We're going to draw the diagonals. Again, here the vertices is going to be on the x-axis with coordinates 4, 0 and negative 4, 0. Now we need to calculate the foci. So the foci is going to be at 5, 0 and negative 5, 0. Now the asymptotes, is going to be plus or minus b over a, which is 3 over 4x. Another example from the center, we're going to go 1 unit up and down and 2 units left and right, and we're going to draw a rectangle. We're going to draw the diagonals. Now here the vertices is going to be on the y-axis with coordinates 0, 1 and 0, negative 1. Now we still need to locate the foci. So the foci is going to be at 0, square root of 5 and 0, square root of negative 5. Now for the asymptotes, it's going to be plus or minus a over bx, which is 1 over 2x. So keep in mind, this is my a square. And this one here is my b square. Another equation of a hyperbola, but we need to divide every term by 225. Simplify. Now, from the origin, we're going to go 5 units up and down and 3 units left and right. We're going to draw a rectangle, take the diagonals. Now here, the vertices are going to be on the y-axis with coordinates 0, 5, 0, negative 5. And for the foci, again, we have 0 square root of 34 and 0 square root of negative 34. The asymptotes are y equal plus or minus a over bx, which is 5 over 3. Now we have a hyperbola not centered at the origin, so we're going to first locate the center. Now from this center, we're going to go 4 units left and right and 3 units up and down to draw a rectangle. We're going to draw the diagonals. Now here, the vertices is going to be parallel to the x-axis and midpoint of the width of my rectangle. For the foci, we're going to go 5 units from the center, left and right. For the foci, we're going to go 5 units from the center. And my asymptotes now, because the center got shifted, so it's going to be y minus 3 plus or minus b over a x minus 2, because the center got shifted. Now, for the foci, we have h plus or minus ck, and for the vertices, we have h plus or minus a, comma k. Now we can locate what are the foci and the vertices from the graph, where are they, but we also have a formula for that. Another example. So first we're locating the center, then from the center we're going 5 units left and right and 2 units up and down. We're drawing the diagonals of that rectangle. Now here the vertices is going to be parallel to the y-axis, and midpoint of my length is the foci is going to be square root of 29 from the center, and the asymptote is going to be as such. Now again we have a hyperbola, and we need to do completing the square. So we're going to rewrite this equation by completing the square. We're going to graph the hyperbola. And here's the equation of the asymptotes. And now we're seeing the foci. We need to find the standard equation of a hyperbola given the conditions. So we know the vertices and the foci are on the y-axis. So the vertices are plus or minus -1. So therefore my a squared is 1. Now we have the foci. We can calculate b squared. So b squared is 8. Another similar example. Another similar example, but here the vertices are on the x-axis and the foci are on the x-axis, therefore a squared is given. Now, parabolas. A parabola is a set of all points in a plane that are equidistant from a fixed line called the directrix and a fixed point called the focus that is not on the line. So now we have the standard form of equation of parabola with the vertex at the origin. We have y squared equal 4px or x squared equal 4py. That's if the vertex is the origin. And we have the graphs as such. Also, we can have opening downward or opening to the left, depends on p. Now, in this example, we need to find the focus and the directrix of y squared equal 12x. Now, 12 is my 4p, therefore p equal 3. Therefore, the focus is 3, 0, and the directrix is x equal negative 3. The directrix is x equal negative 3. The focus is at 3, 0. Keep in mind the vertex is still the origin. Now we need to graph x squared equal negative 8y, and we need to find the focus and the directrix. Still negative 8 is my 4p. Therefore, p equal negative 2. Therefore, the focus is at 0, negative 2, and the directrix is y equal 2. The latest rectum is the absolute value of 4p, which is 8. So keep in mind the latest is 4 units from the focus, left and right. So the latest rectum, the absolute value of 4p, so the latest rectum is the absolute value of 4p, which is 8, is 4 units from the focus, left and right. My vertex is still at the origin, and the directrix is y equal 2, and the focus is at 0, negative 2. Now we need to write the standard form of the equation of parabola with focus 5, 0 and x equal negative 5. So the solution is y squared equal 20x. The focus is at 5, 0, and the directrix is at x equal negative 5. Now, if the vertex is not the origin, we have the following formulas. Keep in mind, if p is positive, it's open to the right. If p is negative, it's open to the left for the first equation. If p is positive, it's open upward, or if it's negative, it's open downward for the second equation. So we need to find the vertex, focus, directrix of the following parabola. So my h is 3. My k is negative 1. Therefore, the vertex is 3, negative 1. Now, 4p is 8. Therefore, my p is 2. Therefore, the focus is at 3, 1. And the directrix is at y equal negative 3. And the graph is as such. Notice the latest rectum is the absolute value of A is 4 units left and right from the focus. Now the last thing, we're going to review the distance between 2 points. So the formula is as such. And that was it for conics.